in last lesson we started off with trying to find the value of theta there, and when you worked it out on your calculator, you ended up with 43.7 degrees. You gave each other a pat on the back, and then I told you all that you were wrong. And you can see visually that it's wrong because the angle is clearly not acute. It's obtuse. It's between 90 and 180. And yet you got 43.7 degrees on your calculator. And from that, we discussed the idea that actually, although we'd extended our idea of being able to deal with triangles that were other than right angled, we hadn't actually thought about what does that mean for theta being bigger than bigger than 90, sorry. And the reason why that was an issue is because if we have a look down here, my little pointer's not showing up on the screen. If we have a look down in slide 3, you'll see that in a right angled triangle, the other two angles can be at most, well, they will add up to 90 degrees. So the other two angles in the triangle must be less than 90 degrees. Okay? So really, right angled triangles have always only ever dealt with angles less than 90 degrees. That led us on to this thing here, where I redefined trig. Obviously, this is not my redefinition, but this is how mathematicians have redefined trig so that we can deal with angles above 90 degrees. And what I asked you to consider is a right angled triangle. I'll zoom up now so you can see it. A right angled triangle where the corner of the right angled triangle, the vertex, is at the origin on a graph. And then I took 1 unit length away from the corner, like so. So we've got the hypotenuse being 1. And then I said, on the Cartesian plane, that is the coordinate x, y. For some value of x and y, we haven't figured that out yet. I also said that between the x-axis and this blue line here, an angle is formed, and I called it theta hat. Just the theta symbol with a little hat on top. Okay, so we have an angle of theta hat. The distance between that corner or vertex and the right angle is x because it's there's an x coordinate. And the height of this triangle, i.e. from the right angle to the top of the hypotenuse, is y because we just called it the y coordinate for some value of x and y. What I then asked you to consider is what does that mean in terms of sine and cosine? Now, sine is opposite over hypotenuse. Now, the opposite is y. The hypotenuse is 1. And so sine of theta hat must be just y. Cosine of theta hat, similarly, is just the x value, x coordinate. Cosine of theta is x over 1, which is just x. And that's what we have over here. Sine of theta hat is y, cosine of theta hat is x. What this allows us to do is it allows us to consider cosine and sine of an angle as a point along this 1 unit length hypotenuse here. Okay? Now, the reason why we do this is because I can now flip this particular line here and flip it over to this side. And I've done this in slide 8. It's exactly the same angle between the x-axis and the blue line, theta hat. But now, if I take it from the x-axis, from here in a counterclockwise direction, I've now got an obtuse angle, theta. Okay, so I can talk about the sine of theta and the cosine of theta as being the y and the x coordinate. The x coordinate is cosine of theta. The y coordinate is sine of theta. Okay? For the same reasons as I said before. It's going to be, now if I zoom back and have a look at it, this value of the y value here, the length from the x-axis up to the end of that unit length line here, must be the same as the length here. Right? Because theta hat is here and theta hat is here. It's the same triangle, it's just flipped over the y-axis. It's flipped. However, the x coordinate is different. The length is still x, So for the distance from the origin to the right angle is still x, but because I've gone backwards, it means the coordinate is negative. So what does that mean? It means that in this quadrant, there are 4 quadrants, 4 sections. In this quadrant, cosine is positive and sine is positive because so are the axes. But in this quadrant, y is positive but x is negative, which means that y, sine of x, is positive and x, cosine of theta, sorry, is negative. Okay? So the cosine of theta is negative. The value of cosine of theta is basically theta hat's cosine value, but made negative. And hence we have this kind of relationship here. Theta hat is just, theta is just 180 minus theta hat. So going back to the original problem, 43.7. So if I go 180 minus 43.7, I will get 136 degrees. Okay, so that angle there is 136 degrees. The cosine of 136 degrees will be, I can't do it because I haven't got the right values here. But sorry, using the sine of 136 degrees will work for this particular equation. Okay? Right. So, moving forward, the summary will hopefully make this a little bit clearer. For an obtuse angle, so for theta between 90 and 180, for an obtuse angle, sine of theta, the obtuse angle, will be the same as the sine of theta hat. Have a look at the diagram again. Here is theta hat here. It's been reflected over here, but the sine will be opposite over hypotenuse, opposite over hypotenuse. It's the same value. It's the same vertical distance away from the x-axis. It's the same value. Y and y are the same. So sine theta will be the same as sine theta hat. It's the same coordinate. It's the same y coordinate, just on the other side. Okay? So if I go along here, choose a color I haven't chosen before. If I go along here, I'm saying this is y, and if I go along here, I'm saying this is exactly the same point, it's y. Okay? So it's the same value. And so sine of theta is the same as sine of theta hat. It's the same value, same sign. Cosine of theta will be the same value, cos theta hat, but it's negative. It's negative. So if I go back here, this distance between here and here will be the same as the distance between here and here. It's got to be. However, we've gone backwards here, and so the cosine will be negative x over 1. So it's negative. This is positive x over 1. So cosine is negative in this quadrant, but sine is, cosine is negative in this quadrant, sine is positive in that quadrant. And then I went through a couple of examples and gave you a worksheet to work your way through that. So in all practicality, what you're doing is, if you're given, without a calculator, if you're given the cosine of 120 degrees, you can work that out by determining what the cosine of 60 degrees, 120 plus 60 is 180, and then making it negative. In a future part of this course, very soon, as in probably next lesson, it was supposed to be this lesson, you will actually get your formula sheets out. Actually, Callum, I gave out yellow corner sheets to everyone. I'll give you one as well in case you've got one already. If you have a look at the third page, up the top, it's yellow, so you should be able to get your hands on it pretty quickly. Not just turn around and look at someone. Not someone, at someone's. You'll miss out on, I'm not waiting for you. You're probably better just to turn around and look. Or just go, yeah. So the third page, at the top, can you see that there's a table of values? They're in radians, but pi on 6, for example, is 30 degrees. So the sine of 30 degrees is a half. Can you see that on the table? The sine of 30, oh, that was quick, you're right. The sine of 30 degrees is a half, yeah? That means the sine of 150 degrees is a half. Does that make sense? The sine of 30 degrees is a half. That's like the y coordinate. So if I reflect that over to the other quadrant like I've been doing, 180 minus 30 is 150. So the sine of 150 must also be a half. No, the sine is positive because it's the y coordinate.
So if it's the cosine of 30.
Let's have a look at the cosine of 60 on your graph. Can you see that the cosine of 60, which is pi on 3, sorry. The cosine of 60 is a half, can you see that?
Pi on 3 is 60.
So go across until you get to pi on 3, and then go down until you get to the cos x line. Can you see how it says a half? So the cos of 60 degrees is a half. Guess what the angle is that the cosine is negative a half?
120. Yeah.
120. 180 minus 60. Yeah?
Yeah.
So if you can do it if you want to, but if you go cosine of 120 in your calculator, it'll output minus a half. Same value, different sign, because it's a different quadrant. Okay, let's push on. That deals with quadrant 1 and quadrant 2. Here we go. In slide 13, which I'll zoom up on in a second, you can see that theta is now a reflex angle. It's between it's between 180 and 270. The angle is between 180 and 270. However, there's an angle here which is the acute angle, which I'm calling theta hat. Okay? That's going to be 180 plus some sort of acute angle. Okay? E.g., 225 degrees is 180 plus 45 degrees. And that is theta hat. Oops. So I might ask you for the sine of 180, the sine of 225 degrees, or the cosine of 225 degrees. It's going to be the same as the sine or cosine of 45 degrees. Have a look at your table. 45 degrees is pi on 4. On your table, what does it say the exact value of pi on 4 is? Root 2 on 2. In fact, it's the same for sine and cosine, isn't it? Okay? So it's root 2 on 2. So that's the value, but what's the sign? Is it positive root 2 on 2? This is the only thing you have to decide. Is it positive root 2 on 2 or negative root 2 on 2? Well, let's have a look at the x and y coordinate. In this quadrant, x is negative. So is y. So the sine of 225 degrees is negative root 2 on 2. Root 2 on 2, because that's the value I get from theta hat, and negative root 2 on 2, because we're below the x-axis, so y is negative. We're also to the left of the y-axis, So that means x is negative. So the cosine of root 2 on 2, the cosine of 225 degrees is also negative root 2 on 2. Okay? So what are you doing always? You're trying to work out the acute angle, which I'm calling theta hat. You're working out the acute angle. You're working out the sine and cosine of that acute angle. And then you're working out which quadrant it's in to determine whether the value is positive or negative. And that's it. Believe it or not, it's as simple as that. Simple doesn't mean easy, right? I'm just saying it's a countable number of steps you have to do. The rest is understanding. Zooming out, zooming in. This one's also a reflex angle, but now it's between 270 degrees and 360 degrees. Well, what's happening here? The acute angle, theta hat, is here. I'll do a different colour, it stands out. The acute angle is theta hat, and as always, it's always between the x-axis and the line. It's never between the y-axis. Okay, so we've got our acute angle. If I'm, an example of this would be, let me see, 360 minus 30, 330 degrees. 330 degrees is 360, notice I'm taking it from the x-axis, 360 minus 30 degrees. So that is theta hat. It's the acute angle that's formed. So if I said to you, what is the sine of 330 degrees? Look at your table. 30 degrees is pi on 6. What does it say that sine of pi on 6 is? 1, is it?
1 on 2.
1 on 2, a half, is it? Right, so sine of 30 degrees is a half. Okay? That's the value of the sine of 330 degrees. That's also a half. But is it positive or is it negative? So let's have a look at the coordinates. Good. X is positive, y is negative. And that means cosine is positive, but sine is negative. Cosine is positive, sine is negative. Now, that means that the sine of 330 degrees is negative 1/2. Sine of 30, so what's the acute angle? 30 degrees. What's the sine of 30 degrees? A half. So the sine of 330 is negative a half. Yeah? This is tough stuff, trust me. Good news is a mnemonic is coming our way to help us remember when it's positive and when it's negative. Again, this is really important foundation stuff though. Cosine of 30 degrees, look on your chart, pi on 6, down to the cosine line. Root 3 on 2. Is it positive root 3 on 2 or negative root 3 on 2? It's positive root 3 on, well, yeah, in the table it says root 3 on 2. The cosine of 330 degrees is also root 3 on 2, but it must be negative or positive? Positive root 3 on 2, because it's along here. Okay? Every single quadrant has its own pluses and minuses for each of the trig functions. I'm very aware that I have not yet talked about tan. It's coming. This one here, how is this different from, how about looking at, I'll just leave it like this, slide 14. How is 15 different from 14? Yeah, well, it's going clockwise, but that's negative. Yep.
Oh,
Yep. So it's going a clockwise direction, and that's negative. So an example for slide 15 is like negative, what have I picked on yet? I'll go negative 60 degrees. okay? That's negative 60 degrees. So it's already an acute angle here, so that's what theta hat is. It's 0 minus 60 if you want, but that's theta hat is the 60 bit. It's the acute angle bit, okay? It's the angle away from the x-axis, it's 60 degrees. So theta hat is 60. What is the sine of 60 degrees? Look on your table. Pi on 3 is the column, sine is the row. Root 3 on 2. Okay? So root 3 on 2 is also the value of sine of negative 60. Is it positive or negative? Well, in this quadrant, we're in the positive x, but negative y quadrant, and y is the sine value. So the value of sine of negative 60 is negative root 3 on 2. What is the cosine of 60 degrees? Look at your table. Pi on 3 is the column, cosine is the row. It's a half. So the cosine of negative 60 is also a half, same value, but what's its sine? Well, in this quadrant, we've gone x positive, so it's also positive a half. You getting a feel for it? It's the same, so work out the acute, or theta hat, the acute angle, find out what the exact value is of that, and then once you've worked out the exact value, you can then just determine what the sign is, not SIN, but SIGN, whether it's positive or negative. And then your job's done. Last one. Snail shell time. This is positive, but it's gone round more than 360 degrees. I'm keeping in degrees, by the way, just I didn't want to put radians to really blow your mind. I just thought you had enough going on. So this, for example, is 390 degrees. That would be 360, one rotation, plus another 30 degrees. 30 is going to be your theta hat, the angle between the x-axis and the blue line. The sine of 30 degrees, check your table, pi on 6, is a half. It's in this first quadrant where both sine and cosine are both positive. So the sine of 390 degrees is also positive a half. The cosine of 390 degrees, well, what's the cosine of 30? Root 3 on 2. You can look at that up in your table. Pi on 6 is the column, cosine is the row. It says root 3 on 2, right? Root 3 on 2. It's in this quadrant, and so cosine is positive. Therefore, the cosine of 390 degrees is also root 3 on 2. You getting a feel for it? Just a feel for it. What we're really doing, you know how like in chocolate wheels and stuff like that, where you're just like spinning a wheel and seeing what number it appears on, what number it arrives on? It kind of feels like that for this, in that what you're doing is you've got your origin where you're standing and you're spinning around, and what you're looking for is where is it landing, which quadrant is it landing in. If it lands in the first quadrant, then the value you get out of it is positive. If it lands in the second quadrant, the value you get out of it is positive if it's sine, but otherwise it'll be negative. If you spin around and it lands in this quadrant, then cosine will be negative, so will sine. If it spins around and ends up in this quadrant, then cosine will be positive, but sine will be negative. Okay? So, which quadrant is it in? That'll tell you the sine. What is the acute angle? That'll tell you the value. Here we go. Hello. Finally, tan time. Tan, a couple of ways of looking at it, but I think this is the way I'll go. What is the right angle definition of tan? Sorry? Total, yeah, opposite over adjacent. Opposite over adjacent, right? Cool, here we go. Look back here to the very beginning and look at this diagram here. I'm saying that tan is opposite the y length over adjacent the x length. This over this, y over x. If I'm dividing a vertical length by a horizontal length, does that remind you of anything? Gradient. Rise over run. So a triangle, when you think about it in terms of the unit circle there, tan is a bit like a gradient. I might keep that unzoomed. So what? So if it's like a gradient, then if the line is going left to right upwards, that's positive. And if it's going left to right downwards, the gradient is negative, right? Just by looking at it. So let's go back and have a look at this diagram here. I didn't do one in this quadrant. Oh, I did here. Can you see how in this quadrant here, the line left to right is going upwards? So guess what the value of tan is? Positive. It's positive here as well, right? Because it's still going upwards. Here, it's going down. Guess what the value of tan is? Negative. And there, it's negative, right? So tan is positive in these two quadrants and negative in these two quadrants. Up, down. Okay? That's the construction of the mean. That's why tan is effectively, here you go, I'll give you a quick identity. If tan of theta is rise over run, that's basically y over x, which is sine of theta over cosine of theta. And that is true as well. Sine theta over cos theta equals tan theta. It's called an identity, it's always true. So if I gave you a number like 12 and I told you to type in tan of 12, you'd get a number out of it. If you then went sine 12 over cos 12, like on your calculator, you would get exactly the same number. Tan is sine over cos. I've got 4 minutes left. Sorry about not having much work to do. We'll do more practice next time. So I want to finish off this video. So here's the mnemonic to finish us off, okay? The mnemonic, the way of remembering. We've got our 4 quadrants here. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Everything, all 3 trig functions are positive in the first quadrant. In the second quadrant, remember, tan is going downwards, so tan is negative. Cosine is also negative. So guess which one is the only one that's positive? It starts with psi, ends in the sine. Here, tan is positive, so it's going upwards. But cosine will be negative, and so will, cosine will be negative, and so will sine. And so the only thing that is positive in the third quadrant is tan. In the fourth quadrant, sine is negative, tan is negative, but cosine is positive, and so cosine is positive in this quadrant. I've got 3 mnemonics for you for that. The one I learned was in quadrant order, you've got all students take care. That's in quadrant order, A, S, T, C. Here's another one I've seen. No one wants to remember this one, though, but I'll say it anyway because it is one common one. SA, in Australia, SA always means South Australia. So South Australian Technical College, there you go, SATC. But what have I called this diagram up the top there? cast diagram, and it's in capital letters for a reason. Starting off from quadrant 4, what does that word mean if you go round it counterclockwise?
Cats.
Cast, if you go round counterclockwise. For those who are not struggling with dyslexia, it's cast. Okay? Have a look at your yellow sheet next to that grid. Next to the grid we were just looking at, the cast diagram. The rest we have a video. Anyone got any questions?
No, sir.
Okay, I'm going to finish off with slide 19, and then next lesson, tomorrow's lesson, I'll finish off with examples and give you plenty of practice times, okay? We're a bit behind our schedule now, but good. So let me finish off, yeah? So the general approach. Number 1, what quadrant will the angle end up in? Spin the chocolate wheel, and it finishes here in this quadrant. That means cosine will be positive, all else is negative. Okay, just focus. For my sake, if you could stop talking and stop packing up, for my sake, it means that I don't have to be distracted. Thanks. Okay, spin the chocolate wheel, it's in the fourth quadrant, therefore only cosine will be positive, everything else negative. Okay, that's that bit there. What's theta hat? Always between the line and the x-axis. So if it ends up here, it's either it's between here and here. If it ends up in the second quadrant, it's between here and here. If it ends up in the third quadrant, it's between here and here. Okay, so always between the x-axis. So you do that. So you work out what theta hat is, work out what the sine, cosine, or tan of theta hat is, and therefore work out what the sine, cosine, or tan of theta is by applying the value and the sign, positive or negative. Alright, I'll stop the video. So I just wanted to quickly ask, and it doesn't need to be captured on video. That was rude, whoever yawned so loudly.